exercise 16.1. We'll give it a crack here. What's the longest pencil that can be stored with a cylinder of height 15 and base radius 4? Now see the way the base radius is 4, that means the base diameter is 8. We know the height is 15. So we're essentially dealing with a triangle where the height of the cylinder is 15, the diameter is 8, and it's a right angle. So 8, 15, and this little red line here, that represents the straw there. So we knew Pythagoras' theorem to find out what the maximum height would be. So it's going to be x squared equals 15 squared plus 8 squared. You know that's 289 when you put it into the calculator. Square root 289. And we know that the answer is 17. Okay, so question 14, the answer is 17. Let's go for question 15. Vertical buildings on horizontal ground is 5 meters tall. The building requires an outside support beam to prevent it from collapsing. The maximum amount of space to erect a support beam is 12 meters to the left of the building. Okay, so essentially there's a support beam, lads, and just imagine this. This is a really short support beam. This is a really long, this is a medium support beam. This is the support beam they give us in the question, and this one is the longest support beam. It can go anywhere in this 12 meters is where this support beam can go, okay? So just bear that in mind. Find the maximum length a support beam can be. Okay, so maximum length would be this here. So if this is 5, this is also 5. So for its maximum length, we're talking a length x. So it's going to be x squared equals 5 squared plus 12 squared. We can use Pythagoras' theorem because it's a right angle triangle. Then we get x squared equals 25 plus 144. X squared equals 169. Square root the 169 to get 13. So the maximum length the support beam would be 13 meters. An engineer calculates that a support beam reaching up to a height of 4 meters on the building would be more effective. So essentially what we're doing here, guys, is that this support beam is no longer at the top of the building, it's now a bit lower. Okay, so that obviously shortens its length. It's now only 4 meters up. Okay, find the nearest centimeter the maximum length. So we want another maximum length support beam in this scenario. So in this case, the 5 will get replaced with a 4. So it's the same calculation again. So it's going to be 12 squared plus 4 squared. Put it into your calculator. And you get 160. Now we got to get the square root of 160, which is 4 root 10. And 4 root 10 needs to be converted into decimals. And it needs to be to nearest centimeter. So it was 16.649, which would be round off to 17 centimeters. Okay. Done. Okie dokes. Further analysis shows the optimum best angle for the support beam is 45 degrees to the ground. Find the length of the support beam correct to nearest centimeter if the point of support is at 4 meters high. So guys, the thing about 45-degree angles is this. In a 45-degree angle triangle, so what we'll do is we'll just, I'll get you onto a new page actually, okay? So imagine this, guys. Imagine we had a line here like so. And we can clearly see that the adjacent is smaller than the opposite. So I'm just going to get a protractor here. It has to be at 45 degrees, lads, okay? So we'll just put our angle here, and then we're going to measure it, okay? We can see that we're somewhere in between 20 to 30 there. Okay, usually it tells me what it is over here, 26. You see the little indicator there, it tells me it's about 26 degrees. Now, the trick is with trying to make it 45 degrees is that the opposite and adjacent sides actually have to be the same length. So what I can do here is if I try and make this, let me see if that's 13 on the money. Okay, if I try and turn this one into a 13 as well, we might have a chance of making it into a 45-degree angle. Basically, the adjacent and the opposites have to be equal to each other. Just going to bring this down here. Now I'm going to hopefully turn this one into 13 as well. Oh, sorry, my fault. So let's hope it 13. No, it doesn't fit. So look, we'll make both of them a bit shorter. How about I turn the bottom one into 10? Might be, or sorry, turn the bottom one into an 8. Might be easier than what I'm currently trying to do. So this is 8 centimeters. For argument's sake, this one is shorter. Okay, then here's our hypotenuse, which is way too long at the moment. Okay, so we put that back in, like so. Okay, now here's what we're going to do. It's 8 centimeters is the bottom side for this one, and then when we look at the length of the top one, like so, we can find out that this length is not 8, it's 3. So if it's 3 up and 8 across, you can bet that your angle is going to be small, going to be quite small. So this angle this time is once again roughly 22 degrees, in between 22 and 23 degrees. I want it to be 45 degrees. So to make this 45 degrees, what I could do is I could increase this length up to 8 centimeters so that the adjacent and the opposite lengths match each other exactly, okay? So when I match this up to 8 centimeters, then I obviously bring the hypotenuse up where it belongs. This time you can see that this is very close to 45 degrees this time. There you go, 45 to 46 degrees with an error. So to get the angle at 45 degrees, you need the opposite and the adjacent sides basically the same length. So this brings us back to this question here, where this time we're going to make the support beam a lot shorter, like so, but we're going to make it 4 meters across, 4 meters up and 4 meters across. Okay, so that's what we're doing this time. So once again, we're going to use Pythagoras' theorem, except this time it's going to be 4 squared plus 4 squared. Okay. 4 squared plus 4 squared is 16 plus 16, which is 32. Root 32 is 4 root 2. So square root 32 and you get 4 root 2. You can see that in your calculator here, 4 root 2. Oh, sorry, root 32 is 4 root 2. And 4 root 2 in turn is 5 point, let's call it 5.66 to 2 decimal places, got the 56 here around up to 60, so 5.66. Now how many decimal places does it want me to do? To the nearest centimeter, so x would be 6 centimeters, okay? Lastly, give one reason why you think this mathematical model would be suitable or not in practice. Which mathematical model? Well, it depends on the building. I suppose limitations could be that there might be not a good fixing point here. There could be a window on the far side of the building. There could be something down here like a drain hole, so it won't allow you to get the exact measurements for a 4 meter by 4 meter support beam. So there's many reasons. Just any valid reason will do you there. Okay. Now, so I think I'm meant to be going to question 16 now. Here we are. Now question 16. An oil rig is 20 kilometers east and 15 kilometers north of Innisol. Calculate the direct distance x from Innisol to the oil rig. So what we're going to use is the bottom triangle here, and we're going to use Pythagoras' theorem to calculate the length x, which is from here to here. Okay, so here's what we're going to do. We're going to say x squared equals 15 squared plus 20 squared. X squared equals 15 squared, which is going to be 625. And x equals the square root of 625, which is going to be 25. Okay, we're all good there. So we know that that's 25. The safety inspector flew directly from this place to the oil rig, which is 12 kilometers west of that one. 12 kilometers west being left 12. Okay. How far south is the oil rig? So we just have to find the y value. That's quite easy. So once again, Pythagoras' theorem, 16 squared equals 12 squared plus y squared. I think it's 256 for 16 squared, yep. 144 for 12 squared and then y squared. Then do 256, take away your 144, which is 112, equals your y squared, and then square root the 112, and we get 4 root 7. And 4 root 7, when you put it into your calculator, or root 112, is 4 root 7, which is 10.583, and in turn would be 10.6 centimeters. Okay guys, and that's us done with questions 14, 15 and 16, I believe. Yeah.